Okay, folks, sorry about that. I've turned off my notifications, so hopefully we won't get any more pop-ups. Before, in the last one, we were talking about exceptions. Now, water does exactly what we think it should. The hydrogen's a +1, the oxygen's a -2. Given there's two hydrogens, two plus ones adds up to +2, one oxygen adds up to -2. Therefore, the whole lot equals 0. It does what it says on the can. Let's now have a look at something weird. If I have a look at H2O2, hydrogen peroxide, it exists in nature, it's a real deal, it exists, it's a thing. If I have a look at this, following our rules, this should add up to 0, and it certainly does. The problem now comes with, I know both H and O, it's something I come across a hell of a lot. So let's go with the two options. And the two options are, I know hydrogen, hydrogen is a +1. I've got two hydrogens, therefore I've got a +2. That means oxygens have to be -2. And given there's two of them, that means that each oxygen equals -1. This is weird. -1 is not what I expect. I expect oxygen to be -2 because that's what it is every time I use it. Let's go with the other option. And the other option is that H2O2, this time I go with what I know, and I'm going to say the one that jumps out, the one I know off the top of my head, is the oxygen one. The oxygen one is -2. There's two of them, so that's -4. -4. That means the height. Come on, man. Just froze for a minute. We're back on track. That means the hydrogens is +4. That means each individual hydrogen is +2. Once again, we've got something weird going on. Hydrogen, we know, is plus, not +2. Therefore, something is wrong. That means there has to be an exception. So the idea is, I didn't want you to kind of memorize this significant little weirdness. I wanted you to be able to work out what the hell's going on. The idea is, these pluses represent the ions that they form. Now, hydrogen does form plus. We are likely to get a H plus. Oxygen doesn't really form a minus. But a minus means that it's gained one electron. That's certainly possible. The spaces in its outer shell for two electrons. It would probably prefer to steal two electrons, but it's possible it could steal one. So this is unlikely, but but not impossible. If we look at the other option, well, the oxygen is a 2 minus. That's certainly what it does normally. That's certainly the thing that we like. On the other hand, the hydrogen, it's saying it's a 2 plus. A 2 plus. Now, that's not something we would expect. So it's unlikely. But what a 2 plus means is that this thing has lost two electrons. It's lost two electrons, is now a +2 charge. If we ever think about it, though, hydrogen's only got one electron. It's impossible for it to lose two. Therefore, both of them are likely. Only one of them is impossible. Because this is impossible, it means of the two options, this one, however unlikely, has to be the one that's right. And that's the way exceptions work. The exceptions are, they might be unlikely, they might be unexpected, but they're the only possible way that these things could happen. This is one mentioned in the study design exception. I wanted you to understand why it's an exception. Add another new slide. I'll go for the second type of exception. We call these metal hydrides. Basically, you've got a metal joined to a hydrogen, or a couple of hydrogens. Let's go for a nice simple one that we should know off the top of our heads. Sodium hydride is NaH. Once again, if I go with what we know, it's going to add up to 0. That doesn't change, that's true. If I look at this, I should probably know off the top of my head that Na forms a plus and H forms a plus. That means I'm expecting, if all things work out well, I'm expecting both of these to be a plus. Let's see what's going to happen here. If I go with the sodium as the one I know, okay, you're a plus. That means you have to be, that means this is weird. It's weird, but is it impossible? I don't know. Let's find out. Let's go with the other option, with the hydrogen being the thing I know. Once again, it's going to add up to 0. Put it in here. This time I'm going to go with this is the one I know. I've got one of them, which means I need the sodium to be a -1. One of them has to be wrong. One of them has to be more unlikely. So the idea is, I didn't want you to memorize so much as have a look at it and go, that's weird. So if we look at the two situations, what I'm saying in situation number 1 is sodium is going to lose an electron. It's got 1 electron in its outside shell. It's in group 1. We would expect that to happen. That's what we'd expect. That's what happens all the time. The hydrogen, on the other hand, we normally expect it to lose an electron, but in this case, it's gained an electron. Let's have a think about that. He's got 1 electron in his outer shell. He only is occupying 1 shell, therefore that's the shell that can have 2 electrons. Given that, it is actually possible. It's possible. It's possible that instead of losing an electron and becoming no electrons, it's possible that it could gain an electron and fill that outer shell. If we look at the other option, certainly the hydrogen is doing exactly what we expect. This is doing something weird. Let's have a look at what it's doing. Sodium has got 1 electron in its outside shell. What this -1 charge suggests is that it's actually stolen an extra one. So it's suggesting that sodium is stealing 1 extra electron. It's now going to have 2 in its outer shell. That makes it further away from what it really wanted, which is to have a full outer shell. That means that while really, I guess, technically possible, it's really, really unlikely. And given that that is unlikely, we're going to say that that one's wrong. I hope that you understand these ideas, that this is the most possible, most likely. This is the one we're going to go with. Just to clarify, of the 2 exceptions that we talked about hydrogen doing weird things over here, and hydrogen did weird things because it's the most likely scenario out of these 2 options. The other one that we looked at was this one, and this is where oxygen did the weird thing. And once again, it's not about memory, it's seeing if you can explain what the hell is going on and why. Okay, team, I hope this is working for you. I'll post this one up now. Stay safe, stay tuned for a couple of questions we'll go through and we'll see if we can understand. Peace out.